Hey guys, this is day 12 of the Leetcode challenge, and let's look at today's problem. Last stone weight. Okay, right. So we have collection of stones, and each stone has a positive integer weight. Okay, and each turn we choose two heaviest stones and smash them together. I like smashing. Suppose the stones have weights x and y, and x is less than y. The result of the smashes, if both are equal, both are totally destroyed. If not equal, then the stone of weight x, which is the smaller one, is totally destroyed, and the stone of weight y has new weight y minus x, which means y loses its weight by x amount. Okay. By the end, there is almost one stone left, which is evident because at every time we take two stones and smash them, and only at most one stone is left. Return the weight of this stone, or zero if there are no stones left. Okay. Right. So when this zero can occur, basically if you are given 1 comma 1 as input, which means both stones of same weight, then by this condition x equals to y, then we will have to return zero because both stones are totally destroyed. Right. So let's look at the example they have given. So they have given example which says 274181. Fine. 2 we take the 7 and 8. This array left and blah blah blah, and 1 is the answer. Fine. So what is our thinking? Okay. Since we need two heaviest weights and smash them together in every time, let's just sort this array and take 7, 8, 4, 2, 1, 1. Right. And we smash them together, and now we have 1, 4, 2, 1, 1. We again sort this array, and we came to this array. Now we take the first two element of the array, we smash them together, we get this array, and we again run a sort function on this. Right. So we have this one naive algorithm, which basically each turn we have take 0 and 1 stone, smash them, put them back in the array, sort the array, repeat. Okay, there are a few problems with this solution actually. First of all, suppose our array is decreasing in length, right? We are smashing stones and we are destroying stones. How we keep track of this? How we do this? So what we can do is, when we take 8 and 7, we can put back y minus x comma minus 1 over here instead of 8 and 7, right? So this array will become 1 minus 1, 4, 2, 1, 1, right? 4, 2, 1, 1. And when we will sort this array again, the minus 1s goes at the end of the array, and we can ignore them when we do our stone smashing. So minus 1 is our placeholder for stones, doesn't exist. Okay, cool. We have solved the problem of decrease in length of the array. Right. Now let's calculate the runtime of this algorithm. Right. So smashing takes order 1, right? And in each smash we only reduce stone by 1 unit. So we need n times smashing, right? And after each smash, what we do is we sort the array. We sort the array, and which takes order n log n time, and repeat this. So basically, what our algorithm will run is, our algorithm will run n log n into n times, right? So n square log n, which is not that good. So how do we get a better algorithm? Since we only need the first two highest element, what we can do is we can build a max heap, right? Max heap basically gives us maximum element in this data structure, right? And we pull this off, and again the maximum number in the remaining data structure percolates up as the root of the tree. So if we build a max tree on the given input, it would be something like 8, 7, 4 2 1 1, something like this. Basically max will always be at the root, right? So what we can do is we can, our algorithm now becomes construct heap, right? Second, pop from heap. Third, pop from heap again, right? Which basically gives us two matched stones, right? Fourth, smash them together. If we have stone left, if we have stone left, then put it back in the heap. And fifth is basically repeat step 2 until heap has two stones, right? So this is basically our better algorithm. So let's calculate the runtime on this algo, right? So if we calculate the runtime of this algo, then a construct a heap basically takes us order n. Popping from heap takes us order 1. Popping from heap takes us order 1. Smashing takes order 1. And repeating takes order n times. And actually when we put it back, we actually have order log of n, right? I'll actually write this in a better way here on the top, which means we are constructing the array, constructing the heap, plus we are doing n times into log n times of adding the stones back, right? So which means our algorithm comes n log n. Great. Is there a better algorithm? Can we do it in order n?
Right. So it's very hard to get an order n solution because somewhere you need to insert the remaining stone after smashing back into any data structure, either an array or the heap. And you need to be able to extract out the second two maximum values. So you need to reshuffle the values around and percolate the values, the maximum top two values up into the data structure. So let's just code the simulated solution using a heap. Basically, we just follow this algorithm, what steps we need to smash the stone and use the heap as mentioned before and get a n log n solution. Right. So we'll code in Python 3. Let's just import heap q and heapify a stone's value. Now, one thing to notice is heap q in Python is a a min heap actually. So it will percolate the minimum value up. So in order to convert this min heap to a max heap, what we can do is a trick where we insert the inverse values, the negative values, which means instead of inserting say value equal to 5, we insert -5, we insert -5. So basically, if 5 is the highest value that should have been percolated up into the heap will instead percolate -5, which is the most negative value. So when we extract this out, we can again do negative on that, and it becomes the actual value which we want, right? So what we do is we actually replace our stones array with the negative value of the actual stones array, right? And we just list on this, right? So we have mapped each of the value of the stones into a negative value, then heapified it, right? And then what we do is we extract out stones. So while length of stones, we want to pop a stone from heap. So we heap pop from stones, and this becomes the highest value. Now remember we have negatify the array, so we have to instead do a minus heap here. So, and in order for convenience, what we can do is we can define a lambda function here, which will make everything negative or the inverse of it. and this actually makes our code much more legible. NX, we extract out X stones. Okay, great. Now, if y minus x is greater than 0 as per the rules defined, we need to insert the value back into the heap. Now again, we need to insert the negative value of this. Okay. Now actually what if we are only left with one stone, and actually there can be two outcomes, either we are left with one stones or zero stones. So what we need is we need to end this while loop when we are either have zero or one stones, and then check if len of stones is equals to 1, then return negative value of heap pop of stones, basically the last stones, else we just return 0. Right, and this is negatifying the values for max heap. I'm just commenting out some things. Okay, great. Let's run this code. Okay, and submit this code. Okay, accepted. Right. So it was a very simple solution where we actually just simulated whatever the steps were there in the problem itself. And the thing was only to find the optimal way for simulation. So the optimal way to get out the X and Y, basically the two heaviest stones, was the trick in the question. So thanks for watching this video, and subscribe to our channel for upcoming lead code challenges and even other lead code problems. Thank you.